the ambiguous case. Now, the Sine Rule comes with its problems. And one of the problems is that sometimes when you're being given if you've been given the dimensions of a triangle, you can actually create more than one triangle based on the info that you've been given. And instead of writing out any notes for this, because it's basically just applying rules, I'm just going to show you an example of this. You need to always test for this whenever you're given the situation in which you have let's do it like this. 1 times, we'll go like this. So if you have 2 times side lengths and 1 times non-included, why did I put an N there? Included angle. Okay, so the ambiguous case, it has to involve these 3 things. Okay, any other situation, you're fine to just use the Sine Rule with no repercussions. If you've been given 2 side lengths and a non-included angle, however, then you need to actually have a think about, you have to actually think about what shape this is making. Okay, so we're going to jump into an example of this straight away, just to show you exactly what I mean. So in triangle ABC, given that A is equal to 40 degrees, BC is equal to 20 centimeters, and AC is equal to 30 centimeters, find the sizes of the other angles. So that's finding angle B and angle C. So we're going to start off by drawing this picture. So the only thing we know about this is that, so let's say A is here, B is here, and C is here, or something like this. Or we'll just start with A first to begin with, actually. All we know about A is, so if I make a straight line like here, that it's going to go 40 degrees in this direction. That's all I know about A. Now let's say this is C here. Now, from A to C, it's 30 centimeters. Seems pretty reasonable already, doesn't it? So no issues there whatsoever as of yet. Now the next thing that we know is about this corner here connecting with something here. And why I'm hesitant to put anything is because we know that it's 20 centimeters. Okay? So, actually, you know what? I'm going to do it this way. I'm going to put my B somewhere down here, so we don't know where it is yet, but we know that C is up here, and it is 30 centimeters long. Now, what you'll notice about this triangle is that 20 centimeters is a lot less than 30 centimeters. Now, we don't know how long this length is here. It could be this long, okay, it could be that long, we don't know. But what we do know is that connecting from C to some point down here, it's 20 centimeters away. Now, that could mean that I'm connecting it to a point here to make let's make it a bit more obvious. Like a point here, which I'm going to call B1, which is 20 centimeters long. Okay? Or alternatively, so that's one of the options it could be. Alternatively, I could have another length down here that's 20 centimeters long and gives me a second point and a second triangle. So in fact, the whole idea behind this is that there are 2 possible triangles I can have in this situation. So what we need to do is we need to check, well, do we have 2 triangles at work? Are there 2 triangles that I can make with this information? Long story short, for this situation I can, but most cases I can't. So what we're going to do is we're going to be applying the Sine Rule to find these missing angles. So let's start off by finding B. Now B can be 2 different things, okay? And depending on what B is what's going to change C. So if B is actually this angle here, okay, then C is going to be a much sharper angle than, say, if B was out here, then making C a bigger angle, okay? So what we need to do is we need to have a look and see in which case it is. So we'll start with the acute angle, so this angle over here, okay? And to do this one, I'm going to call it B2 in this case. So we're going to use our Sine Rule. Now, the 40 corresponds with the 20 centimeters. It doesn't matter if it's this one or this one here. They're both 20 centimeters. and B2 is always going to be corresponding with 30 centimeters, okay? So to find a missing angle, so the way I showed you how to do it in the other video was to do it this way. However, if we're finding a missing angle, all we need to do is take the reciprocal of both sides, and we get this way, okay? And we can use that second one as our rule. So let's use that one. So we're going to go sine B over B is equal to sine A over A. Now let's substitute some values in. Well, I don't know what B is yet, so I'm going to put B2 in, but I know what little b is. Little b is equal to 30. And that's equal to sine of A, which is 40 degrees, over sine, or not sine, but over 20. Now to rearrange this, what we're going to do is multiply both sides by 30, leaving sine of B2 on the left. Oh, don't know what happened there. And then sine of 40 degrees over 20 times by 30, because we're multiplying both sides by 30 on that side. And that gives us sine of, actually, and then to get B2 by itself, I almost forgot the last step, we're going to take the inverse sine of both sides, okay? And you can put that straight into your calculator, like this. It will give you an answer out, that will work. So in this case, B2 is equal to sine of -1 of something. Put it into calculator, and we get that it is approximately 75 degrees, okay? So if B2 is equal to 75 degrees, then what's C going to be equal to? Well, to do that, we're just going to do 180 degrees minus the 40 degrees minus the 75 degrees. Okay, so 180 minus 40 minus 75 is equal to 65 degrees. Now, that's for the acute angle, and that one all works, okay? Now, before we try and see, so this is talking about this little acute angle in here, okay? So this little acute angle in here, it's quite cute, is 75 degrees, which makes the bigger of the two the acute C angles 65 degrees. Now, what we need to do is we need to work out what the other angle possibly could be, or in fact, if it makes a triangle at all, because we've come up with a picture that sort of, yeah, you know, I can see there's like, you know, this triangle here with the obtuse angle, and this one here with an acute angle. It's not always going to work in a lot of cases. In fact, in some cases when you've got this situation, it might not actually produce one, because this side length actually won't work for an obtuse or an acute angle, okay? So to double check and make sure that an obtuse angle will fit in this triangle, because like, you know, if it turns out that this angle in here is 170 degrees, like this can't exist, because 170 degrees plus 40 degrees, well, that's what, 210 degrees. Can I have a triangle where two of the angles add up to 210 degrees? What's the third angle equal to? Well, it can't. So we need to actually check to make sure that this angle in here, is it going to be something that I can, like, you know, I can actually work with? So the way we're going to do that is we're going to do it by using the acute angles, the what are they called? I keep forgetting. The related acute angles. So draw your thing. Whereabouts is 75 degrees? Well, 75 degrees is about there. Okay, so 75 degrees is this height in here. So 75, which makes it 75 there. So the related acute angle in the second quadrant is this 75 degree here, okay? And if I have that acute angle in there, so it means I've got 15 degrees in here. So 90 plus 15 makes 105 degrees. So 40 plus 105 degrees. Okay, so that's actually what my second angle is in here. So I don't actually have to do any of my sine rule, because I'm just using the fact that the related angle, okay, this one in here is 75 degrees. I'm using the fact that that related angle here is equal to 105 degrees to get that one. Okay, because remember, sine's always going to have two answers between 0 and 180 degrees. Okay, what happened there? Between 0 and 180 degrees, okay? Sine will always have two answers between that, okay? And so we just need to make sure that the second one, so it's 105, actually fits in, okay, with that stuff. So 40 plus 105 makes 145. So what does that leave us over with for our second one? So our second C value must be 35 degrees then, okay? So what that's saying is, well, that the big one, so if I use the small acute angle, then big C, so big C, I'll put big, is equal to, what did we decide? It was 65 degrees. But small c, if I use the obtuse angle, is 35 degrees. So basically what I'm saying is there's two possible triangles for me to draw, okay, that has 20, 30, 45, okay, and another one that looks a bit more like this that has 30, 20, 45, okay? So that's effectively what I'm saying. I've got two triangles that I can draw from this situation, okay? So I need to find what both B and C are in both of these cases, okay? So to find B, well, we use the acute angle first. So this is a summary, basically. We find the acute angle first, okay, by doing sine rule. So sine rule. And then we find this one by using the related, okay? It's the related acute angle from that one here. Okay, so sine rule, related acute angle, and then C you just do by 180 minus the other two. So that's been the the sine rule ambiguous cases. So just make sure to look out for those in every situation, because you might be asked to find what both of them are. Okay, you might be asked to use the related angle. Just keep it in mind for when you do these. With that being said, that's the last of the sine rule and the area formula, and we'll see you guys in the next bit.